Okay, in this video, we're going to be simplifying the expression 3ab times the polynomial 5a squared plus 3ab minus 2b. So this is going to require some distribution here. So we'll distribute 3ab through this. 3ab times 5a squared is going to be, well, when you multiply monomial expressions, multiply the coefficients. So 3 times 5 is 15. And you're going to add the exponents of the similar variables. So we are doing a's times a's here. So a by itself is implied to have an exponent of 1. So when we multiply a times a squared, we're going to get a to the third. And since there are no b's in this other expression, the b is just going to come along for the ride. Now we're going to go through and distribute it to the second term. So 3ab times 3ab. So multiply the coefficients. 3 times 3 is 9. And then when we combine our variables, we have a to the first and a to the first, making it a to the second. And b to the first times b to the first gives us b to the second. Then we have one more term. I'm going to switch it. There we go. 3ab times negative 2b, multiplying my coefficients, is negative 6. And then when we deal with our variables, there are no other a's in the second expression, so I'm just going to bring the a along for the ride. And then we have a b times a b, which gives me b squared. Just one more mentioning with this, you should, or I guess two more, you should combine like terms if possible. This one, we have no like terms. The second thing is, as you're distributing through, it doesn't matter what order you're writing the variables in when there's two variables here, but I recommend having a consistent order, whether you put the a's first or b's first. This way, if there are like terms, it's easier to spot. My consistent orders, usually I just put them in alphabetical order. Helps me keep everything straight and helps me not miss any like terms that I might be able to combine otherwise. Okay, so here we're going to simplify the expression. We have a product of two polynomials, the first polynomial being 2x plus 7, and the second polynomial is 3x squared minus 7xy minus 6y squared. So we're going to require distribution to do this, and we're going to need to distribute the first term through. So 2x times 3x squared, multiplying my coefficients, give me 6. And whenever I deal with my variables, make sure to add the exponents, giving me x to the third. Then 2x to the first times negative 7xy, multiplying my coefficients, I got negative 14. And then combining my like variables is going to give me x squared, and the y just comes along for the ride. Then 2x times negative 6y squared is going to give me negative 12 after multiplying the coefficients. And there's no variables that we'll be able to condense here, so x, y squared. So with the last example, it helps to have a consistent order, and I'm just writing it so it's alphabetical order with my x's coming first. Then go through with my second term, y times 3x squared. No coefficients to multiply. If it does help, you can put it as 1y. I do know that helps some people. But 1 times 3 would be 3 for the coefficient. And there's no variables to combine, so I'm going to write it as x squared y. Again, writing them in alphabetical order so that it makes my like terms easier to spot. And then y times negative 7xy would be negative 7. X will just come down, but we'll have a y times y giving us y squared. And then 1y times negative 6y squared will give me negative 6y to the third, adding the exponents with the y's. For this one, I do have like terms to combine. Usually I recommend working just from left to right with multiple variable expressions. Sometimes there is a handy order that people would put it in. Really, it just depends on your teacher's preference as to what order they want you to put it in. But just working from left to right here, there are no other x squared, so that's just going to come down. Let's see. Next, we have negative 14x squared y and any other x squared y's. Yes, we got 3x squared y. So negative 14 plus 3 is negative 11x squared y. And then the next term working from left to right is an xy squared. There's also an xy squared here. So negative 12 minus 7 is negative 19xy squared. Then we have one term that's left, not underlined. So I'm just going to bring down my minus 6y cubed. And that is it. You'll notice if you do it in that order, one of the orders people might request things for or in, and I wrote that one exponent wrong. That's x cubed, not x squared. But one of the orders people might request this in is so that one of the variables is decreasing from left to right. So you might notice as I wrote the terms out, if you focus on x squared, that, or x to the third, that variable is decreasing from left to right in terms of its exponent. So sometimes that's an order that's helpful to write the expressions in, is just focus on one variable and work from left to right with that variable. Sometimes you look at the combination of the variables for their highest exponents. Sometimes it's just whatever order you get it in. So the order for these are a little bit unclear of what you might see answers for multiple choice wise, especially with some of the some other problems. This one would usually be in this order if you were to see this on a multiple choice type of question. But if there's more variation in the exponents, the order is kind of obscure as to what it might be in. So just make sure to check terms, make sure they're matching up, whether then they're in the same order or not if we're talking about a multiple choice question.